Hello and welcome to the second video that has to do with the science part of Science and Scripture. My previous video was on kind of a mixed history of the relationship between science and faith in the last 500 years or so, and we dipped a little bit back even before that. But in this video, I want to talk about the Big Bang, so-called, and Christian faith. Now, I've found in the past that some of my students tend to react negatively to the idea of a Big Bang. And I think the reason why they react negatively is because they associate the Big Bang with a kind of atheistic sense of the universe's origins. But as I have said, the idea that the universe began with a bang, there's nothing unchristian about that at all that I can think of. It has to do with the how, and really the why is the part where our Christian understanding most comes into play. I'm not saying that our Christian faith can't come into play with the question of the how as well, but the question of the why or the behind causes and reasons, that's where our faith primarily lies, or you might say even the who of creation. But the idea that the universe began with a bang, I can't really think, I mean, I've thought about this a lot for years. I cannot think of anything unbiblical or unchristian about the idea that, bam, stuff began. And so the only thing I can come up with is people associate this idea of a bang with an atheistic, but why can't it be theistic? Why can't it be God who says, and God said, let there be bang, and there was bang? Or in the beginning, God created the heavens and the earth, and there was heavens and earth. So I'm always open to being corrected, but I don't see any basis for saying that a bang in and of itself is unbiblical or unchristian. In fact, we're basically, when we say, and this is something I'm going to argue in this video, when we say that the universe began with a bang, we are saying that the universe had a beginning. And if the universe had a beginning, that raises the question of, well, why did it have a beginning? And this we call God, as Thomas Aquinas would say. One of the fundamental arguments for the existence of God is the argument from cause and effect, or the cosmological argument. It basically says that the universe needs to have had some cause behind it. And this is what we call God. And no doubt we'll get into that whole question of the cosmological argument at some point. But I want to focus on the science in this video. A tale of three theories. So if we were transported back 70 years, say to the year 1950, and in the late 20th century, we would find that there were three basic scientific theories for the how of the origins of the cosmos. And I'm talking about from the scientific standpoint. I'm not talking about the who or the why. I'm talking about the how of cosmological of the universe's origins. So the preferred theory at the time was the so-called steady state theory. And on the steady state theory, the idea is that the universe has pretty much been here forever, and that's, that matter is somewhere being generated, and maybe somewhere there's a drain hole of matter, where the matter is disappearing, and somewhere else there's a faucet of matter, and the universe is in this steady state of matter coming in and matter going out, and basically the universe is a eternal kind of entity. And this was, I would say, the preferred understanding of how the universe came to be around the year 1950, 60, and so forth, in circles that were talking about these things. This would have been the view that Einstein, for example, preferred. More on this in a moment. Then there was the Big Bang theory. And actually, as I'll say in a second, the guy who came up with the phrase Big Bang was mocking it. Yeah, Big Bang, the Big Bang theory, everything, bam, everything was here. And what you'll find is that he didn't like it because he realized that might point to there being a God. And so this is the irony, is that I hear a lot of people a lot of Christians opposed the Big Bang Theory. That's not the way scientists of the 1950s and 60s saw it. They made fun of the Big Bang Theory because they thought it might imply that there was a God. And Einstein didn't like this theory because, again, it suggested there was a creator of some kind. And so interesting how things, context changes the perspectives on things. Of course, the third perspective was what we might call the oscillating Big Bang theory, or I might call it the rubber band Big Bang. Boom, everything explodes, and then the gravity kind of says, wait a minute, don't run so fast, and then gravity pulls everything back on itself, and it collapses, and then boom, and then it collapses, and boom, and then it collapses. This was, say, for example, Stephen Hawking's favorite theory, until it basically was shown that it's not the case. And this is the interesting thing, because what we're going to find is that science itself, and I'm not talking about Christian science, I'm talking about secular atheist scientists. Not all scientists are atheists, of course. Francis Collins is not an atheist. But what we find is that in the 1960s, the steady state theory was eliminated because it was come to conclude, and of course there is a provisionality to a lot of this. This is science in this area is talking about really ultimate things, and so there is more provisionality to cosmological origins theories than probably there are to other aspects of science. But anyway, given the current state of scientific thought, in the 1960s, the steady state theory was eliminated. And then more recently, actually even maybe within this millennium, from 2000 on, the oscillating Big Bang theory was considered to be not likely because of not being enough matter in the universe to slow it down and stop it. In fact, the current theory is that the universe is both expanding, and it's expanding faster and faster and faster. And so, far from slowing down, the current sense of things, again, it may change, but the current sense of things is that there's not enough mass for it to collapse in and of itself. So these were the main theories, scientific theories of cosmological origins in the 1900s. Steady state theory, the Big Bang theory, and the oscillating Big Bang theory. And from a scientific standpoint, which one of these fits the best with Scripture? Well, it's the Big Bang theory. That is the idea that at some point in the past, there was a beginning to the universe, and the universe began with a bang. And so again, I can't think of anything unbiblical about that. Now, so where we get into debates is the question of how long ago that might have been. That's where the debates begin to start. Okay, a tale of three theories. Okay, I want to give you some background in the theory of relativity. So Einstein came up with basically two layers to the theory of relativity. The special theory of relativity, Einstein came up with in the year 1905. And he was trying to solve a speed problem, the speed of light problem, because it would seem that, if I were to stand on a train and throw a baseball forward, what would be the speed of the baseball? Well, the speed of the baseball would be the speed of the train plus the speed that I threw the baseball at, A plus B equals speed of ball. But what had been discovered in the 1800s is that the speed of light is a constant. It doesn't actually vary at all. And so Einstein put his head to trying to solve this problem. And what he concluded is that space-time is relative to speed, that the faster you go, space contracts from the standpoint of someone looking on. Time appears to move more slowly as we approach the speed of light, for example. Similarly, space appears to contract as we approach the speed of light. And so this keeps the speed of light constant because space-time behaves differently depending on what speed a particular inertial frame of reference is moving. This is very interesting. And it may seem speculative, but experiment has verified these sorts of things. For example, there's a particle known as a neutrino. Neutrinos do not stay in their neutrino form for very long at all. And so it should be the case that neutrinos should not reach the Earth's surface, because the time it would take a neutrino to get from the upper atmosphere to the surface of the Earth is too long for the neutrino to survive. And yet neutrinos make it to the Earth. And so what's up here? Well, the solution is that since neutrinos are moving close to the speed of light, space contracts for them, and time contracts for them. And so they are able to make it to the Earth's surface because their space-time matrix is shorter than what we would think of as the normal distance from the atmosphere. It's all very heady stuff, the stuff for geniuses and such, although I think we can basically understand it. But this was the special theory of relativity. And then 10 years later, he followed it up with the general theory of relativity. And this has to do with large objects like the Earth or like the sun. And so what he postulated is that time appears to move more slowly around massive objects, and that space appears to contract also around massive objects. Again, this has been confirmed by experiment. There was a famous experiment having to do with the motions of Mercury, for example, that couldn't be explained, and that the general theory explained. Our GPS devices take this into account. And so if it weren't for Einstein's theory of relativity, our GPS wouldn't work because they would be off because of the gravitational pull of the Earth. So even though this sounds fantastical, it has been confirmed by actual scientific experiments. They've even taken planes and flown them in opposite directions around the Earth. And then they synchronized a clock in, I think it was London, before the plane took off, and then had the plane move around the Earth and come back. And when they got back, the clock that had been on the plane and the clock that had been on the Earth were out of sync, pretty much exactly the minute amount that Einstein's theory of relativity had predicted. Well, this is very interesting, but what it suggests is that space is not a container in which the universe is, but that actually space can expand and contract. And when it comes to God, I may talk about this in our live session, when God creates the universe out of nothing, it's not just a matter of God putting stuff into empty space. Creation is not, we have this empty container that God starts throwing stuff into. But creation out of nothing implies that God creates the emptiness of space itself. Now, I can't even conceive of what it would be like for there to be not even emptiness. We might call that empty set. There's not even zero in it. God creates the universe out of empty set. He doesn't create the universe out of zero. And this blows my mind, but it suggests that God created everything, and that God created the rules for everything, and God created the space, time in everything. And so to me, this has astounding implications for God's knowledge, for God's power. It basically supports the classic understanding of God as omnipotent and omniscient, and on a level that I'm not sure that a lot of people have even famous theologians throughout the centuries, because the theory of relativity didn't come around until the 1900s. I doubt that there was any Christian thinker who could have thought some of the thoughts that we can think about what it means for God to create the universe out of nothing. But I don't want to get too far off track, so let me stick to the script here. So eventually, especially in the late 1900s, a hypothesis basically developed, of an inflationary period. It was what developed in the late 1900s, this idea that the universe started as a point and expanded into the massive thing that we now know. I mean, that's just, my mind can't fathom it. I can get the idea, but it makes no sense. But the idea that the universe, that when God started, he created a dot, and that from that dot is everything that exists. This is the current theory. Backing up a little bit to 1913, a guy named Vestos Slipher observed the red shift. Now, I don't know if you've ever, paid attention to an ambulance or a fire truck as it goes by, you know, da da da, or this is the British, da 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 da. You know how the tone goes down as it goes by you. This is called the Doppler effect, and so this happens with light too. And so Vesto Slipher observed that when you aim your when you do a spectral analysis of far off stars, there is a shift toward the red end of the spectrum, which suggests that they're moving away from us. And so this was the first hint that and of course this happens no matter where you aim your radio telescope, you know, into the sky. What you find is that everything is receding away from everything at massive, what seem to be massive speeds to us. And so there's this sense that the universe is expanding at every point, from every point. There's no center. Everything is just expanding everywhere. And then in 1917, Willem de Sitter, he noted that Einstein's equations, his general relativity equations, could be taken to imply that the universe was expanding. That was a potential answer. And in fact, in 1922, Alexander Friedman found an error in Einstein's math. Einstein, by the way, this is very hard math from what I understand, but Einstein himself wasn't that, I mean, I'm sure he was better than any of us, maybe not some of you, but Einstein wasn't, let's just say that he didn't teach math. He needed some help from David Hilbert in developing his general theory of relativity. But basically, Alexander Friedman found an error in Einstein's math pointing toward an expanding universe. Well, Einstein was not happy with that because again, this is just funny to me that people are so opposed to the idea of a Big Bang, because the scientists didn't like Einstein didn't like the Big Bang because they knew that it suggested that the universe had a beginning. And if the universe had a beginning, that would play into the hands of people who believe in God. And some of these scientists didn't like that. And so Einstein, this circumstance irritates me. That my own math is betraying me. And I'm not saying Einstein was a bad person, but he clearly was an atheist. I mean, he has a famous quote, "God doesn't play dice," but he didn't literally believe in God. That was a kind of a figure of speech to him. He was talking about how he didn't like another part of physics that developed in the 20th century, quantum mechanics. He didn't like it. To him, it was like God playing dice with the universe. Anyway, that's a different story. Next week. Okay, so Einstein was annoyed that his own equations could imply an expanding universe. Then in 1927, a man by the name of Georges Lemaitre, he published a paper that again, by the way, this is a Roman Catholic priest. This conflict between science and faith has not always been the case. Georges Lemaitre is an example of yet another Christian who saw the ability to integrate his faith in the universe with the science that was coming out. And so he published a paper which was largely ignored, by the way. His paper and he was largely ignored until some years later when the Big Bang Theory proved to actually be the most likely of the three main theories. 1930, you may have heard of the Hubble telescope, named after Hubble. And Hubble took this redshift theory and concluded that the further away a galaxy is from, the far faster it is moving away from us. In fact, some of them appear to be moving faster than the speed of light, which contradicts Einstein's theory of relativity. Let me give you the answer, at least the current answer. And that is that they're not actually moving faster than the speed of light, but that space itself is expanding, that time-space is expanding. And so they appear to be moving faster than the speed of light because space itself is expanding. Those galaxies aren't actually moving faster than the speed of light. It's space that is, because the space is expanding, they look like they're moving faster than the speed of light. So again, in the 1930s, then they come to the conclusion not only that we're not the only solar system, but that we're not the only galaxy, but that there are galaxies scattered across the universe. So you may know this, you probably do, but let me just reiterate it because maybe you don't. That the current understanding of the universe is that the universe is this vast thing full of all of these galaxies. And we're in the Milky Way galaxy, according to this understanding. And galaxies usually have massive black holes at the center. Black holes weren't observed. Again, the idea of a black hole was initially mocked, but it is now generally believed that black holes have been observed, that there is a massive black hole, for example, at the center of the Milky Way galaxy. And black holes are these superstars, no, literally stars that were huge, that have burned out and collapsed upon themselves and become, I don't know what the size of a black hole is, very, 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 very small. But basically, the matter has collapsed in on itself, and that the mass is, the density of the mass is so great that nothing can escape it, not even light. And so they're like this black emptinesses scattered. And there are more than one black hole in a galaxy, but most galaxies have a massive black hole at their center. At least this is the current understanding. And there are these galaxies scattered all over the universe. And there are these solar systems, which are systems around stars, solar star systems. Our sun is a star. And so we are just one solar system in millions of solar systems in millions of galaxies in one big happy universe. That's the current understanding of things. So there are islands of galaxies scattered across the universe, and these are very far away. The farthest object that's currently known, it doesn't even have a name, as far as I know. It has a number, and it's allegedly 13.3 billion light years away. And they use triangulation and so forth, and so forth. Now, does this suggest that the universe is at least 13.3 billion light years, or 3.3 billion miles away? Well, actually, it's more than miles. A light year. Sorry, let me go back. A light year is the distance light travels in a year. So yes, it would be 13.3 billion years. Because it's taken the light, allegedly, 13.3 billion years to get here. Now, here's where some would say, well, that doesn't fit with the Bible, that the Bible doesn't support a universe that is that old. My personal opinion is that the Bible really doesn't weigh in on the age of the overall universe. We're going to talk about Genesis 1 this week a little bit. And I just don't think that Genesis 1 is talking about how old the earth is. Now, again, you don't have to agree with me, but I'm going to argue that we need to read Genesis 1 in its ancient Near Eastern context. The Genesis 1 was not written as a modern science textbook to answer our questions. Genesis 1 was written in the ancient Near East with two basic points. One is that God did it. That God is the creator. And when you look at Genesis 1, God doesn't fight with anybody. So we have to compare Genesis 1 with the other creation stories where you have gods duking it out. There's no other gods that God dukes it out. So we'll talk about the Enuma Elish, where Marduk dukes it out with Tiamat and other gods. Probably the most striking thing that an ancient Israelite would have had reading Genesis 1 is there is no conflict. God says it and it's done. There's one God and there's no conflict, and God says it and it's created. I think that's the primary thing to take away from the Genesis 1 story. And yes, I think the Genesis 1 story does also imply that there is an orderliness to the creation, that God did it in an orderly way. But I think questions about whether they're 24-hour periods or whether they're ages and things like that, again, you don't have to agree with me. I think that probably misses what the original point was of Genesis 1. That infects the text with our questions, I suspect, and doesn't really inductively listen to what the points of Genesis 1 in its own, what its original meaning and its original context was. We'll talk about that a little bit. You don't have to agree with me at all. but that is the position that I think I'm going to take. I'm pretty sure I'm going to take, unless I change my mind between now and Thursday. But that's my general understanding. The Genesis 1 is not really a blow-by-blow videotape, but it is an introduction to the Pentateuch. Genesis, Exodus, Leviticus, Numbers, and Deuteronomy. It's an introduction that is talking to other creation stories rather than giving us a blow by blow. Now, having said that, there is an interesting parallel between the order of things in Genesis 1 and the way that scientists would say life developed on Earth. So there is a parallel in the kind of structure of Genesis 1 and current scientific thinking even. So again, we'll explore the scripture and the faith part of things when we are together for class. But right now, let's say, so 13.3 billion years is a long time. So can I give you an explanation for that from a young Earth perspective? Sure, I can give you a young Earth perspective on that if you want. And that is that God might have created the light already on its way here. You know, God doesn't, again, I'm not saying that's how God did it, but if you want something to fit this, so if you want an integration, a possible integration of science and faith, you don't have to deny that the stars are that far away. You could say that when God created the universe, he created it to look old. This is called the apparent age theory. So God could have created the light almost here, or maybe all the way here, you know, when God created these. So there are ways to integrate faith and science, even if you say, no, God created the universe 6,000 years ago. You could say, and because he wanted us to have light, he created the light already on its way here. You could argue that. I don't know that it's necessary to argue that, but you could argue that. And so that's called the apparent age theory, the idea that God created the universe to look old, even though it really isn't. And let's face it, I cannot prove, you know, I teach philosophy sometimes, I can't prove that I wasn't created 5 minutes ago with my memory intact. You can't disprove it. You can't disprove that you were created 2 minutes ago with all your memories already there. In fact, I was watching, what was I watching? There was let me try to remember what the movie was I saw not too long ago. Oh, it was Picard. It was a Star Trek Next Generation thing where the Captain Picard from the Star Trek The Next Generation is an old man, and he meets this girl, and her memories are intact, but they're not really her memories. They're implanted memories. I can't prove. Nobody in this room can prove. There's nobody in this room but me, by the way. Nobody can prove that we weren't created 2 seconds ago with all our memories here. And so the idea that the universe only looks really old, so that would be, again, I don't have any reason to think that. I have no reason to postulate that. I'm just simply saying that one doesn't have to deny the apparent observation that stars are that far away. You don't have to deny the science. There are often other ways to fit things together if you need to. But science currently, maybe it'll change its mind, but currently the best understanding of the scientific, best interpretation of the scientific evidence is that there are celestial bodies that are really, really far away. Okay, so all of this is pointing toward an expanding universe. Now, I mentioned Fred Hoyle. I didn't call him by name, but Fred Hoyle was a charismatic personality who, in sarcasm, coined the phrase Big Bang. This is a funny thing about human nature. Human nature likes the person that makes us laugh. Human nature likes the person. I mean, I think it's part of our fallenness. We like the sarcastic person. Not everybody, but I mean, people who make us feel superior to other people by putting other people down. I mean, this is the locker room joke, you know, where you're making fun of some other group. Polak jokes, you know. When I was in middle school, I didn't know anybody who was from Poland. They're just Polak jokes. or blonde jokes, these sorts of things. Something about fallen human nature likes the guy or the gal that's constantly putting other people down. Not everybody, but there is a certain dimension to human fallenness that likes um, the sarcastic, charismatic figure. In fact, most people much prefer that sort of person to any kind of investigation of evidence and truth. I would say this is an unfortunate thing, and it's how people, can come to power sometimes. But Fred Hoyle was a charismatic scientist who coined the phrase "the Big Bang" in sarcasm, and he was a proponent of the steady state theory in the 1950s, especially. Now, the problem is that in 1965, Arono Penzias and Robert Wilson, these were two guys that worked for a company. I'm trying to remember whether it was AT&T. I can't remember who maybe it was Bell Laboratories. I can't remember. But they were pointing their radio telescope out into space for communications purposes. And what they found is they came across this kind of static out there. And they're like, okay, there must be something wrong with our equipment. But what they found eventually, that no matter where they pointed this radio telescope, there was a certain kind of cosmic background radiation everywhere. And what they eventually came to understand is that this background radiation was slowly decreasing. That it was kind of like, think of, let's say that you've had a little fire. You've made a fire outside, and you've toasted some marshmallows, and you've had your marshmallows, and you've put the fire out, but the logs are still hot, right? Or the coals after you've barbecued, and let's say you've used coals. The heat is going to remain in those objects after for a little while, and it's going to go down, right? It's going to get cooler and cooler and cooler. I mean, sometimes, when we cook something, you don't just put it in the fridge. You let whatever it is if you have leftovers that are hot, you let them cool down, and then you put them in the fridge after they've cooled down. Well, there's a sense in which the universe is cooling down. This is what this background radiation eventually was understood to imply. Now, the thing is, if the universe is cooling down, it can't be infinitely old. Because if the universe was infinitely old, then it would already be cool already. And so the fact that this cosmic background radiation was out there and slowly diminishing implied that the universe must have had a beginning. And people like Fred Hoyle didn't like this, but after this discovery of the cosmic background radiation was discovered, they eventually had to admit, okay, steady state theory is out, that there must have been some beginning to the universe. And this was not pleasing, of course, but eventually because they're scientists, they went with the evidence. Now, I'm not quite sure how this works, but here is a mapping that was done in the late 1900s of the cosmic background radiation. This is the universe looking out. I'm not quite sure how it works, but this is the picture that was taken of the cosmic background radiation everywhere. Now you notice that it's not even, it's not completely even. And that would become important in kind of this understanding of how the universe's early days played out. So the current theory is that the universe had a beginning, which of course raises the question, well, why did it begin? And where did it come from? Now, people often say this about God. So you say, well, the universe had to have a beginning, and this is why we believe that there was a God. And then what's the comeback? Well, then where did God come from? That's the comeback. Well, I think this reflects a fundamental misunderstanding of what we're saying, because we're saying, as I look around the universe, I see that everything in the universe has to have a cause. And in fact, that the universe had a beginning from a point. A singularity is a point. The current theory is the universe began as a point. So the universe had to have a beginning. And so it makes sense to ask then, well, why did the universe begin, or what caused the universe to begin. Now, when I say that, I have said nothing about the cause of the universe. There's a confusion. The people who say, well, then where did God come from, are confusing God with the universe. The argument is there must be something outside of the universe that created the universe. I've not said anything about it. My argument is only that this universe needs a cause. And so you see, there's a fundamental blurring. And I think this is true of a lot of thinking, even Christian thinking about God. If God created the universe out of nothing, that God is not fundamentally in this universe. Now, again, God is in this universe. God has come into this universe, but the essence of God existed before the universe. And God created the universe. The universe is something, I would say, other than God. This goes back to our discussion last week about miracles. Again, I'm not that we can debate these sorts of things, but there is a certain profundity, I think, to understanding that God existed before the universe did, and that God created the universe out of nothing, ex nihilo, and that therefore the rules of this universe don't apply to God. This may even be true of logic. Now, a lot of philosophers would say that God can do anything except what is logically impossible. For example, well, I don't know, maybe God can do the logically impossible because God created logic as part of this universe. Again, that's above our pay grade. We can't speak of those things because they're beyond our points of reference. Anyway, the universe began, the current theory is, the universe began as a point, as a singularity at basically when the universe was 10 to the negative 43 seconds old. That's when it was a point. And then this would be the time for a theory of everything. I don't know if you've seen the movie Theory of Everything, which is the story of Stephen Hawking's life. Hawking was the one who he had ALS. I mentioned him last week, and in his late days was confined to a chair and could only speak through the computer. His pursuit was of a theory of everything. Science still doesn't have a theory of everything. I'm sure some Houghton professor will come up with it. But the idea was that at this point, all four forces were the same force. The strong nuclear force that holds nuclei of atoms together, the weak nuclear force that has to do with radiation, the electromagnetic force that has to do with electricity, and then gravity, although I'm not sure that gravity really is a force. But that's a whole different subject matter, quantum gravity. Anyway, so at that point, you have all these four forces being the same basic thing. Then at 10 to the negative 35 seconds after the universe was created, this is a point with 34 zeros after it, and then a 1. This doesn't contradict the Bible at all, because we're not even to 1 second old yet. Then the idea is that at that point, the universe exploded. I picked this off of somebody's blog once. You can see there's God from Michelangelo. And then this right here is the point at which the big, we could call that the Big Bang. Hold on to that thought for a second. But this is where in the beginning, God created the heavens and the earth. And then at not even 1 second, it undergoes this massive expansion into something very vast beyond what we currently would think of. Guth and Lindy are the ones who came up with this theory. And then the further you go over here, you get fundamental particles like quarks, and then eventually you have hydrogen nuclei, and eventually you have solar systems and so forth. So again, the idea of a grand unified theory would apply to this period of creation. So again, here, this is I just was pointing out this diagram. So again, we have fundamental particles. We don't even have atoms yet, and you can see that it's very hot. So this would be a 1 with 32 zeros after it. But the first 3 minutes, this is just 3 minutes old. So that doesn't contradict the Bible. It's when we get to 300,000 years that some would say that we have violated the timeline of the Bible, if we think that's true. But up to the first 3 minutes, there's nothing unbiblical, as far as I can tell, about this theory of how Of course, I don't, as I've said, I don't think there's necessarily anything unbiblical about 300,000 years or a million years or billion years. But we'll talk about Genesis 1 when we are having a live session. But certainly the first 3 minutes, and there's a book called The First 3 Minutes by Weinberg, I believe it is, Stephen Weinberg. There's nothing about this theory that would contradict the Bible as far as I can tell. Okay, I want to kind of end this video with something called the fine-tuning argument for the existence of God. There are several arguments for the existence of God. I mentioned the cosmological argument. It's the argument that God, there needed to be a creator. Another argument for the existence of God is the argument from design. That's the idea that the universe is orderly, and therefore there must be somebody who ordered it. It is quite astounding to me. It is quite astounding to me how many aspects of this theory, the current theory of atheist scientists about the way the universe came together, are completely nuts from a probability standpoint. There are so many aspects to the nature of the universe that could not possibly happen by chance from one perspective. And I just want to share a little bit of this. This is called the fine-tuning argument for the existence of God. I have a video out there on YouTube in which I go through this in more detail. I have a book called Just Six Numbers, I think it is, that again, the person who writes it is not a believer as far as I know, but just talks about how there are so many aspects to this universe that are just so finely tuned that if it was any different, nothing would be here. So, for example, there's no oscillating Big Bang theory because there's not enough material, at least currently as it's understood. There isn't enough mass in the universe for Hawking to have his way, for everything to slow down and then collapse back in on itself. The rubber bang and Big Bang theory, there's not enough matter in the universe for that to happen. Then here's Hawking here in his Brief History of Time, talking about the rate of expansion of this expansion phase. If the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, it would have recollapsed before it reached its current size. So what he's saying is that the way that the laws of the universe are configured meant that the expansion rate of the early universe was just, it's like Goldilocks. Well, this universe is too thick. Well, this universe is too thin. Well, this universe is just right. That the universe's laws were set up just right for it to expand the way it expanded. And that if the expansion rate had been even a little different, it would have collapsed in on itself. Again, isn't that interesting? It's just right. How did that happen? What a coincidence. It was just right. So somewhere before 10 to the negative 10, we're not even to 1 second of the universe yet, sometimes called the quark epoch. Matter wins out slightly over antimatter. Now, I don't know if you've ever watched Star Trek again, but the idea of Star Trek is that it's the Enterprise runs by taking matter and antimatter and exploding, and it goes because of this explosion of matter and antimatter. So the idea is that there was a slight asymmetry. There was slightly more matter than there was antimatter in this very early part of the universe. And the vast majority of matter and antimatter combined with each other and exploded and became energy. But there was just enough difference between the matter and antimatter for the universe to exist. Now, this is a little strange to me because I associate God with symmetry. But apparently God is okay with a little bit of asymmetry. You ever had a picture that's slightly askew and it bugs you? No, I've got to go and I've got to put that picture balance. Well, apparently God doesn't have a problem with pictures that are slightly off. This is more a personality quirk that you can't handle it, perhaps. But God let there be a slight asymmetry. Now, scientists aren't totally agreed on the basis for this asymmetry. I've heard a couple different explanations, but there was just a slight, isn't that amazing that there was just a slight asymmetry because if there hadn't been, none of us would be here. The perfect symmetry would have meant everything, the matter and antimatter would have exploded into and all we would have is energy. But there was just the right, the Goldilocks again. There's too much matter and antimatter in this one, anyway, no, that's not quite right. Anyway, but there was just enough asymmetry for enough matter to be here and just the right matter for it to be the way it is. And so again, isn't that amazing? It was just right. The direction of time gets locked in at some point here in this early period. On the quantum level, time doesn't have to go in just one direction. But at this time, time gets locked into one direction. All the forces are now distinguished. We have the 4 different forces, and they have just the right proportions. And this is important because, like, if you remember having studied an atom in chemistry or maybe in physics, you have competing forces. You have gravitational forces and you have electromagnetic forces. The balance of the forces in the atom are just right. So the strong nuclear force is just right to hold protons and neutrons together in the nucleus. Now, protons and neutrons, the protons in the nucleus, positive like charges repel, right? And so it's possible that you would have 2 like charges in the protons that would want to fly away, but the strong nuclear force is just right to hold the protons together. And the contrast of the electromagnetic force between the electrons and the protons is just right for the electrons to stay around the nucleus. What I'm saying is all of these forces, the gravitational force, all of these forces are just right for it to all stay together and for it all to, isn't that amazing? What's the likelihood that by chance all the forces would be just right? Otherwise, we wouldn't have any atoms, and therefore we wouldn't have any matter. But all of the forces are just right for it to work. Let's keep going. So somewhere before the 3 minutes, protons and neutrons form. There's something called dark matter. Again, we'll see what 50 years from now it's called. This is kind of the part of science that's not at all certain as to what we're talking about here. But apparently, there must be more matter in the universe than we can see. It's angels, really. I don't know what it is, but dark matter is formed in this period. Some protons and neutrons glue together to form helium nuclei, but just the right amount. So not all of the protons and neutrons do this. If all of the protons and neutrons had formed helium, we wouldn't have any hydrogen. And if we didn't have any hydrogen, we wouldn't have any suns. And so just the right amount of protons and neutrons fused together for us to have helium. And the rest is the raw material for there to be suns to form. Again, this is it's the current theory. It's based upon various observation things, but it completely fits with a kind of creator, because we ask, well, how did all this just happen to be just right? What are the odds that it would all be just right? And we're not even we're talking about a whole different level from like evolution. There's the question, well, how could evolution have happened, on its own? Well, this is a whole different level. How could the fundamental laws of nature, to where it's just right for there to be a universe here, how could that have happened all on its own? And then, so the background radiation allegedly happens at about 380,000 years into the universe's creation. That before that you have this hot soup, but at 380,000 years, the idea is that everything cooled down just enough for photons to be released all over the universe. And the background, the cosmic CMB, cosmic microwave background, and this sense of the background radiation, that explosion of light is allegedly the cooling down of the universe enough for the photons to be released. Now, again, it's fun to me. I'm not claiming that God was saying anything like this. Maybe he was, but it is interesting to me that in verse 3 of Genesis 1, after God created the heavens and the earth was formless, darkness was over the face of the deep, and God said, "Let there be light." I mean, the cosmic background radiation is basically ta-da, light everywhere. Sometimes people will say, well, how can you have light before there's a sun? Well, according to current cosmological theory, there was light, photons, long before there was our sun. Again, I'm not arguing that that was intentional in the original meaning of Genesis at all, but it is a fun little parallel between current cosmological theory and the order of things in Genesis 1. Okay, the rest of the theory is stars are burning balls of hydrogen. We'll talk, I think, this week a little bit about, sometimes people talk about a literal reading of Genesis 1. Well, what is the literal reading of Genesis 1? God takes the waters and he divides the waters from the waters, and he puts a firmament or a dome to hold the upper waters back. And then in day 4, he puts stars in the dome. And so if you, a literal reading of Genesis, it seems, would see stars as being lights in the dome, with there being waters above the stars. And so we're gonna talk a little bit this week about whether or not what people say is the literal reading of Genesis 1 actually is the literal reading of Genesis 1. A lot of the ancients viewed the stars as angelic beings, which would completely change the way we talk about the Star of Bethlehem. The Star of Bethlehem would in that, if that were the way it was viewed, would be an angelic being, basically showing the way. Again, I'm not saying that's the right interpretation. I did hear a paper once where someone argued that that's what Matthew had in mind. But we would now say that stars are burning balls of hydrogen. See the Lion King. Anyway, but apparently these stars burn out. So the idea is that our sun is a ball of burning hydrogen, but that eventually the hydrogen will all burn out. And then when there's no more burning, our sun will collapse. Our sun is a fairly small sun. And so the theory is that our sun will collapse into what's called a white dwarf. Maybe our sun will collapse to something about the size of the Earth. It'll still have a lot of mass, but it won't be as like a black hole is a supermassive star that collapses and again is so dense that not even light can escape it. There's a middle star here. Neutron star is a star much more massive than our sun that collapses and is somewhere in between a black hole and a white dwarf. Now, what allegedly happens, again, this is a theory, is that each time a sun burns out, nuclei are fused together. And so whereas it all started with hydrogen and helium, after the first generation of stars burned out, again, this is a theory, you don't have to accept it. Who knows, maybe science won't accept it in 15 years. But the current theory is that when the first generation of stars burned out and collapsed, because again, remember, according to this approach, we have billions of years to work with. So we could be on our, say, third generation of stars, according to this particular theory. And so the idea is that after the first stars collapsed, you had the fusing of helium atoms together into higher metals, so like carbon. Carbon, by the way, again, if this theory were correct, carbon has exactly the right specs, as it were, to form. And of course, carbon is the basis of life. And so if carbon weren't just right, according to this theory, if God hadn't made carbon just right, then we wouldn't have had the basis for there to be life as we know it. And so the idea is then this material kind of gravity over time pulls it together, and we have a second generation of star, and it burns out. And then we have a third generation of star. So allegedly, our sun, again, according to this theory, is a third generation star. Now, so there are two basic ways to approach this. This can't happen by chance. And so, obviously for me, the easiest way is to say, in the beginning, God created the heavens and the earth. And so there you have it. God created the heavens and the earth. But one other approach is something called the Anthropic Principle. And the Anthropic Principle basically says, yes, the conditions of the universe are unbelievably tuned for us to be here, but we're here, we're just lucky. And so the idea is that uh, no matter how improbable it is, we just happen to won the cosmic lottery. Freeman Dyson, the universe in some sense must have known we were coming. He doesn't believe in God. And so either we're fantastically lucky or there was a creator. Now, I want to talk about this fantastically lucky. It is pretty much impossible that we're just impossibly lucky. That just boggles the mathematical probabilities of things. And so there are maybe three current approaches to this. I said two, but I'll go ahead and include Hawking's. So the easiest explanation, the simplest explanation, is that God created the universe, that there is a designer. And remember, some people have thought in the past that evolution has undone the argument for design. The old argument was, if you find a watch, you assume there was a watchmaker. You find an eyeball, you assume there was an eyeball maker. And so some thought after the theory of evolution arose that they had gotten away with the argument from design. But you can see we're looking at the argument for design from design on a whole different level here. That the universe is so finely tuned. If the universe were a hair's breadth, less than a hair's breadth different on so many different levels, nothing would be here. And so by far, the easiest way to account for this is to say there was a designer, that there was a God who created the universe. The anthropic principle works upon the idea of what's sometimes called a multiverse. The idea of a multiverse is that, yes, the mathematical probability of our universe happening by chance is prohibitive, that there's no chance, really. I mean, we might as well say there's simply no chance that our universe is here on this fine-tuned level by chance. It's just not possible. And so, but some would suggest, well, what if there are infinite universes? If there are infinite universes, then there might be a nearly infinite number of universes out there that just didn't work. So there are some universes that as soon as they popped out, they had too much matter and they immediately collapsed in on themselves. Or there might have been some universe out there where it expanded so quickly that stars didn't have time to form. Or there might be some universe out there where the proportion between electromagnetic force, nuclear force, gravity, it was the wrong proportion and no atoms formed. Or there might be a universe out there where there was a precise balance between matter and antimatter and it just all annihilated itself. And so the multiverse theory would say is maybe there are an infinite number of universes out there in a multiverse. And yes, it is highly improbable for any one universe to form, but the fact that we're here shows that we just happen to be the lucky ones in the one universe out of an infinite number that actually worked. Again, maybe some people find that to be a satisfying theory. But of course, then we have the question, well, where did the multiverse come from? Who created the multiverse? In a sense, it takes the question back just one step further. Now, Hawking, as I remember, suggested, well, maybe we don't know much about the quantum level. Maybe the quantum level is such that every once in a while it burps, and here we have a universe. Maybe I'm sure I don't fully understand everything that Hawking was saying with that, but yeah, no. Okay, well, this has been a video about the Big Bang and getting us ready for our talking about Genesis 1. This video meant to give the scientific side of the equation. And then when we meet together, we're going to talk about the biblical and Christian aspects of whether or not this fits. Now, I've made the claim that the idea of the boom, that fits. That the real question has more to do with the question of how long ago the big boom was. But maybe you disagree. And so I look forward to conversation when we talk about whether or not you think that some of this cosmology might fit with a Christian perspective or a biblical understanding. So thank you very much.